Hi everyone. Now, before we go ahead, we'll just quickly recap on what we have studied. We have studied tokenization. What is tokenization? We'll just recap quickly. Uh, so, computer cannot understand words by themselves. Therefore, the words needs to be converted into numerical representations. Now there are we cannot just simply say 1 2 3 4 like for words, but there has to be some systematic pattern. That specific process to convert a word into numerical representations is tokenization. Now there are three types of tokenization. There's word based tokenization, there is character based tokenization, there's subword based tokenization. What is word based tokenization? It's basically whenever you want me to convert a word into tokens, you could just say, for example, the city is beautiful. Every single word becomes a token. uh, but there are certain problems with word and character based tokenizations that I have explained earlier in the video. Then what we currently used is a sub word based tokenization, which used byte pair encoding, which is BPE, to basically define where will we have a split on the word. So then we'll have tokenized words. So now we have a numerical representation of one word. uh, Now we'll understand embedding. Now before we go ahead and understand embedding, we'll just understand how an LLM will understand a sentence. So any, for not just LLM or a computer, but for a human also, when he wants to understand a language, there are three major things that he wants to understand. One is, sorry, one is the meaning, second is position, third is context. Every word in any language has a meaning. Position where that word is placed makes sense. If it is irregular placement of words, then the sentence would not make sense. The context of every word in respect to the other word makes the meaning, like the complete meaning of a sentence. For example, uh, Galway is a beautiful place. For example, Galway is a beautiful place. It's a sentence where every word has a meaning except for the filler words, but the position of these filler words or position of every individual word in the sentence makes sense. For example, if it was Galway beautiful is place a, will not make any sense because the position of the words are jumbled up. So it has to be correct position to make a complete sense. So there are three things: meanings, position, and context. Uh, what which is a beautiful place? Galway is a beautiful place. It's in told in respect to Galway, right? Sorry. So now coming back. Now what these three major things are covered in transformers. The transformers is a combination of these three things. Meaning is captured by embedding layer. Position is captured by positional encoding. And context is captured by attention layer. Now, these are the three major components of a transformer: embedding layer, positional encoding, and attention layer. Except for these three, all the other ones are basically cleaning the outputs, which is normalization, is to normalize and everything. Residual is to take back the previous input in consideration. But I'll explain this all this in detail. But majorly there are three things: meaning, position, context. Meaning is captured by embedding layer, position is captured by positional encoding, context is captured by attention layer. Now we'll go one by one on each, starting with embedding layer. Now what is embedding layer and how does it capture meaning? So embedding layer is basically a layer where through every encoded word would be will be passed to generate a meaning of the word. Now what do we mean by meaning? For example, very famous example, which is a king and queen. These are two words. King defines a status for a male, queen defines a status for female. Now, these both words in perception of status are related. King and queen are of similar status, but in perception of gender, male and female, these two are opposite genders, these two are opposite words. So king and queen are also opposite words, and king queen as a status are one single explanation of one single status, right? But how do I define it to a computer? So what do I do is I place king somewhere, I place queen somewhere. So consider this my entire this space to be my vector space, like a space where I belong. Now I have placed king here and I have placed queen here. Now there are these two spaces in within a single space. I have kept these two positions of a word, king and queen. Now from a certain point to reach king, I need some coordinates. I need, for example, considering two-dimensional, I may need x and y coordinate for that king, and for queen I may need x dash and y dash coordinates. Given that it was a two-dimensional plane, status and gender, but in reality there are more number of dimensions required to represent a word and to reach to that word. So when, for example, if it was 3-dimensional or 5-dimensional or 10-dimensional, it could be returned as x comma y comma z comma a comma b comma c something something, like that. The coordinates could be mentioned like this, and hence the position of the king. Same way, queen can be written as x dash y dash plus z dash y dash comma a dash comma b dash comma c dash, like that. Now these are two different representations of points on a space, because these are vectorial, because these have directions and a placement. These are vectoral representation of those two words. Now embedding is basically trying to place these words in a way that their meaning, same meaning words are nearby to each other, opposite meaning words are opposite to each other, are far from each other, and unrelated words are in different are again a little far from the current words. So basically what I'm trying to do is I'm trying to create a vector space where I could just place certain words in a vector space where closer words are placed nearby to each other and opposite words are placed far from each other, right? So this basically, this complete entire space is called vector space, embedding vector space. What we do is we try to, the current number that usually is used is 512. So what we do is we create a 512 dimensional vector, and there we represent every word. So every word will represent under a 512 dimensional vector representation. So now what we did is king after tokenization, for example, was 93. This 93, instead of giving 93 as a number, what we are giving to a computer is a 512 dimension vector, which is 0.3 minus 0.2 comma 0.9 comma 0.006 comma, like that, till n which is 512 dimensional vector representation for king. Similarly, we'll have something for queen. Now, how would the same meaning words will be closer to each other? So what we basically do to come up with these numbers is basically we run a neural network. So we send these words to neural networks one by one, and then we generate these vectorial representation of all those. So it's just word to vec is one way we could represent a word into a vector representation. Neural network is basically used to represent a word into vector representation. So this is all embedding. Embedding is basically converting the token which was generated by tokenization from a word to a vectorial representation of that word into 512 dimensions, such that closer meaning words are closer meaning words are closer to each other in terms of cosine difference between these two vectors space. And then we'll go ahead on the next session, which is on positional encoding. So now that we have captured what do we say, meaning of the word, we would need to capture the position of the word, how the position is significant, and then we'll go ahead on the context meaning. So embedding is done.